Hello everyone and welcome to DRA demo video for Single Cloud. In this video, we will demonstrate the usefulness of DevOps for software development on the cloud. We will begin this video by discussion about DevOps, history, definitions, concept, practices, and tools. DevOps can be traced back to 2007. It was born from the agile necessity for fast application delivery. There are many definitions of DevOps. For instance, DevOps is considered to be a software development process that emphasizes communication and collaboration in a DevOps team between developers and operations. DevOps is also a software development approach that enables automation in software development pipeline from end to end. Most notably, DevOps extend the continuous development goals of the agile movement to continuous integration and continuous delivery. DevOps approach drive forward the agile software development using a set of concepts. Firstly, communication and collaboration in a team. Then, continuous integration of software development and deployment. Then, the concept of automation in the development pipeline, continuous delivery, quality assurance, and continuous planning in agile environment. In traditional software development, Dev and Ops are widely separated parties. A DevOps team is no longer bound by geography, time zone, or culture. To successfully adopt DevOps approach, an organization should improve communication and collaboration in a team. To effectively do so, organizations will rely on communication tools that provide clear insight into the project and provide real-time communication and collaboration reporting to the team across the pipeline. The second DevOps concept is continuous integration. It is the process of merging developers' code repeatedly using specialized DevOps tool in the pipeline. CI is critical for DevOps approach. This concept can be successful by integrating a number of DevOps tools to create a robust pipeline. A DevOps CI tool is responsible for building a project, running automated testing, reporting those testing to the communication tool, and it is also responsible for continuous deployment. Automation is the core engine of DevOps approach. A DevOps Reference Architecture pipeline is constructed using DevOps toolchain that provide total automation to all software development major steps, such as code synchronization, project build, testing, monitoring, deployment, and application staging. DevOps continuous delivery concept improves the software production cycle by relying on automation concept. An automated pipeline effectively shortens the release cycle. Agile benefits from DevOps CD. Fast agile release means increased production to users. Dev and Ops are involved in all parts of the development cycle. By monitoring in real time the health of the application, the DevOps team can improve the quality of the software by relying on test logs such as unit test and acceptance test. The DevOps team can go back and remodel and replan their application for a next release relying on test logs and acceptance test. This is what we call behavior-driven development. The behavior of an application at runtime affects the next release of this application. Quality assurance is an important target of agile software release. DevOps team can replan and remodel the application based on the test logs from unit testing and acceptance testing in a behavior-driven development environment. BDD in DevOps approach is real-time, which enables DevOps team to adapt and update the software design and plan based on automated test and feedback results. To successfully adopt DevOps approach, there are a set of practices that should be followed. Firstly, DevOps team must have clear insight of software development project. Construct a DevOps pipeline using DevOps toolchain that enable end-to-end automation. The DevOps team must also have an access to all IT operation across the pipeline. The DevOps team must maintain constant communication and collaboration. The team must rely on a communication tool for test reporting, for continuous integration reporting, and for deployment reporting. Adaptive planning based on behavior-driven development, retrospective QA test, and test logs. Also, it is necessary to provide self-management on cloud platform. Increase also application delivery frequency on the cloud. Synchronize critical services, uptime and scheduling, especially on the cloud. Integrate database management tool with the pipeline. There are many other DevOps practices, but the noted above are the most important. As stated earlier, a DevOps reference architecture pipeline is constructed using a DevOps toolchain based on tools that provide end-to-end automation. There is a large number of DevOps tools being used by organizations and researchers. For repository, we could use GitHub or Bitbucket. For continuous integration, we could use CodeShip, Travis CI, and Jenkins. For continuous deployment, we could use also CodeShip, Travis CI, and Jenkins. For monitoring, we could use New Relic and Papertrail. As a database management cloud, we could use MongoDB Lab or DB Maestro. For cloud platform, we could use Heroku and AWS or Azure. For communication tools, we could use HipChat, Trello, and Slack. For testing, we could use JUnit, TestNG, and Cucumber for acceptance testing. In this course, we will construct a DevOps reference architecture based on 5 models. The reference architecture is a language independent, application type independent. In this case study, we will set up DRA pipeline for Maven Java web application. The project type is Maven Web App. Language is Java. For testing, we will use JUnit and Cucumber. For repository, we will use Bitbucket. For CI/CD, we will use CodeShip. As a cloud, we will use Heroku. And we will use MongoDB Lab as a database. For monitoring, we'll use Papertrail. Most importantly, for communication and collaboration, we will use HipChat. DRA composition is mapped into the following table, and it is illustrated as following. This figure shows an abstract layer of the DRA model architecture. The process begins from the workstation when a team member pushes the code to the repository, which is Bitbucket. Bitbucket in turn automatically pushes the code to CodeShip. CodeShip will automatically build the project, test the project, and create a Word file for continuous deployment. Bitbucket will deploy the code on Heroku. Meanwhile, Papertrail will be monitoring the code deployment on Heroku, and the users will have access to the application via Heroku platform as a service. A user can save his data on the MongoDB cloud and also can send feedback to the DevOps team, which in turn can rely on those feedback on the testing log from HipChat to remodel and replan the application for a newer version. As shown in the figure above, the DevOps reference architecture relies on 5 modules: M1 design module, M2 build module, M3 deployment module, M4 monitoring module, and M5 database module. The design module enables collaboration and communication, agile design, source control, retro QA. In order to complete the design module steps, we must rely on tools such as HipChat and Bitbucket, and we also must apply agile methodologies. In a deployment module, we will use Heroku. Heroku integrates with CodeShip, integrates with Papertrail, and integrates with MongoDB Lab. Heroku provides platform as a service for application deployment. Users can access their application once it is scaled up on Heroku. In the monitoring step, we will use Papertrail. Papertrail integrates with HipChat and integrates with Heroku. Papertrail deployment logs are relayed to HipChat along with testing logs, which are unit test and acceptance test from CodeShip, and also the commit logs from Bitbucket. The automated reports provide the DevOps team with a clear insight into the development pipeline. The DevOps team can also redesign the application based on those monitoring reports. In the database model, we will use MongoDB. MongoDB integrates with Heroku. It enables DevOps team to access and manage data stored on the cloud as a JSON form. It could be formatted and mapped into any other data type. At runtime, the web application connector being enable the user access to the MongoDB. The DevOps reference architecture pipeline is illustrated in this figure. The process begins from the workstation. A team member will push the code to Bitbucket. At this stage, Bitbucket automatically will push the code and integrate it to CodeShip. CodeShip will test, build, and deploy the code to Heroku. Heroku in turn will stage it to user devices. The users will use the application and save their data on MongoDB. Meanwhile, Papertrail is monitoring and reporting the deployment log to HipChat. Also, CodeShip is sending testing log of JUnit and Cucumber acceptance test to HipChat. The Bitbucket commits logs also sent to HipChat. All the reports are packed and sent to the workstation to the DevOps team. The DevOps team, based on this pipeline, will have clear insight into the development project and are able to manage their JSON type data stored on MongoDB Labs. There are several steps that should be taken to set up and configure the DevOps Reference Architecture. Firstly, at the workstation, we must create a Maven project. In the POM XML, we must add the JUnit plugin, Heroku plugin, MongoDB plugin, Cucumber plugin. All the plugins should be added to POM XML of the project. At the workstation, we will develop a simple web application using NetBeans and Maven. Also, we will develop a small unit test and a small Cucumber acceptance test for retro QA and behavior-driven development testing. Also, at the workstation, we will develop the connector class to connect to MongoDB and set JSON as a data type. The next step is to set up our Bitbucket repository, clone the repository, and integrate Bitbucket with HipChat and CodeShip using API token. After that, we will set up our own CodeShip project and we'll set up the test script on CodeShip and enable Java and install Maven and enable Maven testing and Cucumber testing on CodeShip. At this stage also, we will integrate CodeShip with Heroku and we will integrate also CodeShip with HipChat. Next step is to set up Heroku and set up the project name on Heroku and decide on the region and the type of application, which is Java, and also decide on the domain name. The most important part of this step is to set up the proc file in the project, which contains the dynos that will scale the application to users. In this step also, we will integrate Heroku with MongoDB Lab and we will integrate Heroku with Papertrail to send the deployment reports to Papertrail and from Papertrail to HipChat. At this step, we'll use the MongoDB URI and set it up in the connector Java Bean class on the local IDE to provide automated connection between the application and the MongoDB Lab cloud. Also, we'll set up Papertrail integration with HipChat that will provide the logs to the DevOps team. Once the application is scaled, the users can access the application using the Heroku provided domain from any device and use the application and save their data on MongoDB Lab. After the DevOps Reference Architecture pipeline is set up, the deployment process will take only 5 minutes from workstation to user devices. DRA evaluation. DRA automate synchronization, build, testing, and deployment. DRA also release an application to user devices within 5 minutes. All team members are notified of the process. The application can be remodeled and updated in short time. DRA maintain software development quality using retro QA testing based on the JUnit test log and based on the acceptance test log. DRA support agile fast release, which deploy an application within 5 minutes to the users. DRA can be configured to any type of application using any programming language. DRA can be configured using different tools as well. DRA implements automated unit testing. It also enables acceptance testing using Cucumber. DRA utilizes the power of the cloud and deploy an application on the platform as a service. Now we will show a small demo that demonstrates the effectiveness of this architecture. We will start this demo from the workstation. Initially, we will set up a new version of the code of the web application and push it to Bitbucket. And then we'll name our commit demo SEP3. Now let's push to Bitbucket. As soon as we push to Bitbucket, we'll check our commit log. We received just now our demo SEP3. If we go to CodeShip, CodeShip automatically received the code from Bitbucket and begin unpacking the project and exporting the environment. Now, after cloning the project from Bitbucket, it will run the testing modules and it will repack the project into a WAR file and deploy it on Heroku. So let's wait until the continuous integration is finished. As we can see, it began compiling the Maven project. And as you can see, JDK 8 is enabled. The whole continuous integration is automatically happening. After compiling the Maven project is finished, CodeShip will start running the Maven testing. In the web application, there are two tests. JUnit test that tests the connection with MongoDB, and also an acceptance test. As we can see, the JUnit test has run already. The test log is very long, but it shows that the connection with MongoDB is successful. We'll scroll down to reach the acceptance test log using Cucumber. As the test indicates, every test connection with MongoDB has a status true. Also, the test using Cucumber has been deployed on CodeShip. Now the Maven project is packaged and tested one more time using the switch E and exported to Heroku using API key. Now CodeShip will push the web project to Heroku and will make it available on the platform as a service. Meanwhile, let's check HipChat. HipChat received a notification from Bitbucket that the code has been pushed, and it just received a notification from CodeShip that the code has been successfully integrated and tested. If we go to Heroku and we open the app has already been deployed. It is a simple app that allows a user to register. Let's say John Smith, and the user password is 123456. Once we register, this data will be saved on MongoDB Lab as non-SQL JSON type data. If we go to MongoDB Lab and go to our users, a user has been added, John Smith 123456. Meanwhile, if we go to Papertrail, we can check the deployment log on Papertrail, and Papertrail also send deployment log to HipChat. HipChat will notify the team with the deployment log, with the CodeShip log for continuous integration, and Bitbucket log. That was the lesson of today about DevOps. Thank you very much and hope it was instructive. Good luck.